Hi everyone, it's Busjockey, Michael Eilbrock. Today I'm gonna start off with the first installment of my heavy duty scope diagnostics presentation. Um, in this presentation, I'm gonna be basically talking about the uses of an oscilloscope in diagnostics on heavy duty equipment, and that can range from anything from a semi truck to a combine, um, to a backhoe, anything that's big. Heck, even on a crane, this a scope can be used, and basically my presentation is gonna be that talking about the different techniques that I've developed over the course of um, about 3, almost 4 years now. Um, so anyway, let's go ahead and get started, and I'll tell you a little bit about myself. I work for the Champaign-Urbana MTD as a full-time transit bus tech. 19 years hands-on experience. I almost actually have about 20 now. And at my job, one of my main tasks, is doing drivability and electrical diagnostics. Um, I'm an ASC certified master transit bus tech, and I'm also a L2 advanced level specialist. I also have factory certifications from Cummins, Detroit Diesel, Thermo King, ZF Transmissions, New Flyer, Gillig, Allison Hybrid Transmissions, Vansco, and Allen Bradley Multiplex. And I also have associate's degrees in automotive and diesel power equipment technology. So what does that mean? It means I have a whole bunch of shiny pieces of paper that basically say I think I know what I'm doing. so, uh, but this is my background, and that's how I got started. Got started in college, and I just kept on wrenching. So that this is me. Okay. Uh, I have a lot of technicians ask me, well, Mike, why do I need a scope for HD diagnostics? And here's some reasons for you. It can help you understand electronic and electrical signals by looking at relationships. They give you a more thorough understanding of the system you are troubleshooting. Um, Scopes can help you find intermittent problems, and they can also help you verify the repair, and you'll be able to prove the repair to your customer by being able to save your captures. That's the great thing about scopes now these days. They're PC based, and you can save the captures, print them out, save them to files, so you can review them for later on. I have tons of files. I have quite a bit. I think everyone will enjoy this. And then the most important thing, it always comes down to this: it's going to help you save time and money. And I also do get questions sometimes from HD technicians. They've never heard of an oscilloscope. So um, to those guys and gals out there that don't know what an oscilloscope is, I just want you to think of it as an oscilloscope is a voltmeter, on steroids. Okay, it can display voltage over time, displayed on a screen, and a scope can take millions of samples compared to a DVOM. So more samples means less important information missed. Okay, so for example, say you're going down the road and you have a low power complaint, and it only say it only happens while going up a steep grade, but it doesn't do it all the time on a steep grade. Okay, so your window of time is very small to catch. All right, so trying to catch something like that with a digital volt ohm meter, it's not going to work. Okay, it won't catch it. It's not fast enough. All right. And then what values can you measure with a scope? voltage, of course, current with a current clamp, and then pressure with pressure transducers, and you can measure temperature. There's tons of different things that you can do with the scope. Um, there's just unlimited options, in my opinion, especially with the newer scopes these days and all the different features they have. And it's only limited to how much you want to play with the scope and figure things out. Okay. All right, and here's an example of signals that you can see better with an oscilloscope. Crank and cam sensors, injectors, fuel pressure reaction to injection. Except that is extremely handy with common rail systems of today, because due to the fact that all the injectors are inside the valve cover, and in order to gain access to them and test them, it's a lot of extra time to do it. I know, I've done it before myself. It's a lot of extra work. Okay. Um, Another example, engine integrity with the use of pressure transducers. Um, the pressure transducers are awesome. Okay, I've actually used them quite a few times now, and there's been some times where we've had an engine where the pressure waveform wasn't uniform for the intake and exhaust, and it ended up being valve lash that was way out of adjustment, like at its max limit. And because of me, tinkering with these buses on my brake and stuff, I helped save an engine. Okay, think about that. How much is a diesel engine normally brand new? We're talking thousands and thousands of dollars. Okay, so this is a money saver too, ladies and gentlemen. Okay, um, injection timing. You can use it to verify injection timing. You can use it to see alternator AC voltage and ripple. With the new electronic systems that are on these vehicles, everyone, um, the less AC voltage that you have, the better off you are. They're not like the systems of yesteryear. Okay, the the limits that these systems can take are not as much as they used to be. All right. So that's another good reason why you want to have a scope to check these things, because one, problem with an alternator or, battery, and it's going to completely mess up the entire system. All right. Um, Another example, wheel speed sensor signals. Very handy, especially on buses where you can't really on some models you can't get to the sensor very well. It's tucked in there and hard to get to. And on some models, it's just easier for me to hook up my scope and drive around the block and come back and see what I got. And then I can tell whether or not I need to go there or not. Wouldn't that be cool if you could use that to figure out whether or not you need to go to the wheel end or not, or you need to, start looking at connections, So it's very helpful. It'll save you a lot of time, and especially save you doing grunt work that you don't need to do. Okay. Um, Another example, opening and closing of solenoid valves by looking at current voltage. Okay. Um, those can be used for checking kneeling blocks. Okay, on buses. Where you have a solenoid that energizes a valve that opens a passage to let air flow into an airbag, or you have a valve that opens to exhaust the air out of the airbag. You can hook up an amp clamp and look at the reaction of that solenoid, and you can tell by that amperage waveform if that valve is opening. And you can also look at the voltage spike on the ground to see if you see it closing. Okay. Now it's not going to determine flow. I know that, but it will tell you if it's opening or closing or not. That's really cool. Okay. So to sum this slide up, there's a lot of advantages in using the scope, and that's my goal here with this presentation. Um, with the presentation, I'm probably just going to do little parts until I'm done, because I don't want to ram everything down everybody's throat all at once. So I think it's better just to do it in parts. So I'll just keep on splitting it up in parts till I'm done. So how about let's go to the next slide. I get questions like this all the time too. What type of scope should I buy? You should buy a scope that's automotive based and that's geared toward, automotive heavy duty use. These scopes have presets to help you and information to help make learning the scope easier. Unfortunately, not as much on my end with HD, and that's because of there's not a whole lot of technicians out there using scopes in the HD world, and that's why. But I'm trying to change that. That's why I'm doing this presentation. I want people to be aware of this, and I want them to see the value in this equipment. Okay. You also should buy from someone that will give you good support and training for your chosen instrument. Okay. So you need to be able to talk to them, and they need to be able to help you if you got a problem. Okay. Another thing, the scope, you should be able to collect large amounts of data. This is going to help you on finding intermittent problems, and I can speak from experience on this. And it lets you look at how the waveform is trending. Okay. So those are some of the key things that you need to look for in a scope. And I know all of you probably know where I'm going with this, and I am. What scope do I use? And of course, everybody knows I use a 4-channel Picoscope. I got it from autonerds.com. I like AutoNerds. That's just me. You guys can buy it from wherever you want, but I like them. It's where I learned how to use a scope, and they've been very good to me. Okay. The Pico, this scope is just a powerhouse. It's got plenty of power and then some to look at drivability issues. It can record huge amounts of data at the graph, and it'll trend the signals, and it samples faster than a scan tool. Okay, that's the other argument that I get a lot too from techs. Well, we got the scan tool. The scan tool can do it. Not necessarily. It can't do it all the time. I've got examples on that too where the scan tool does not help, and the only way to figure it out is to hook up a scope. Okay. So anyway, autonerds.com, they're a vendor for Picoscope. They specialize in nothing but Picoscope, and they provide training support for the tool. These are good guys. They've got a lot of experience under their belt. They're very sharp technicians. So it's the place to go. So they also they offer online forums, so you can actually talk to other techs for help with your captures, which is a big deal with me because I was green when I first started out with this thing, and I got tons of help from everyone. Everybody has just been really good, and they've helped me develop into a better technician. Okay, there's also a ton of good information on there for different vehicles, including HD vehicles. I regularly contribute to the Cummins bus forum on AutoNerds. Okay, so any UHD guys or gals out there that work on Cummins, okay, you need to come to me. I'm on there, okay? And you can reach me too, on different sites too. I'll still help you. But if you want the creme de creme, go to Cummins Bus, okay? I'm there and I'll help, all right? And we've also got a regular HD diesel forum. It's not just Cummins; it's anything HD. There's a lot of other HD technicians on there. I've networked with. We've got some sharp guys on there. I think everyone will be very impressed if you decide to pick a scope up from the Auto Nerds crew. But it's because of us contributing to this resource. The reason why it's so big now, okay? Then another thing that we do every month, we have online training sessions helping you better understand how to use your scope, and we show you techniques being used by other technicians. So it's just a big smorgasbord. Like every month, someone will have a problem, and they'll show a case study, or one month, you know, Tom and Brian will, show features of the scope, how to fine tune it, how to make yourself better. Um, just this is an amazing resource, and I've looked around quite a bit, and for Picoscope, for the training and the content, there is nothing else out there, as far as I know. I've looked around, and I haven't seen anything at all that compares to Auto Nerds. Period. Okay. And of course, is it a sales pitch? Well, yeah, it is. But the reason why I'm doing this is because I think Scope Diagnostics, it's very beneficial for the technician shop owner, and it can overall improve your shop's bottom line. And a lot of people already know me already, and they know that I like to help people, and I like to show everything I know. And also, the people that know me, they also know when I talk about a product and I say it's a good product, it's a good product. I don't pitch stuff unless I mean it. Okay, and it's a good product, it's a good scope, it's a good package from Auto Nerds. This is a good deal. Okay, and that's just how I feel. Okay. So now, another question, can I prove it? I've been talking the talk. Can I walk the walk? Yep, I can walk it. So here's where the fun begins. I'm going to show you some case studies to prove it. The case studies have been accumulated over the last 3 years. With the help of Auto Nerds, my ability to use the Picoscope has exceeded my expectations. Okay, so here's the bread and butter, okay? So we're going to do this one case study, and then after that we're going to end it, and then I'll then start another part for everyone to see. So I don't know how many parts this is going to be, but we'll just roll with it and see what happens, okay? So first bus, 0328, it's a 40-foot New Flyer Cummins ISC with a CAPS fuel system. The complaint is you got a check engine light with a 121 code. This code indicates a loss of the engine position sensor signal. Okay, the bus has been back twice. We have tested the harness for open shorts and short to power. Everything's okay. So after these tests, the engine speed sensor was replaced and the camshaft position sensor was replaced. Okay, and it still didn't fix it. So next question, what else could be causing this issue? Okay, so next thing I did, I back probed the engine speed sensor, the cam sensor. I put a low amp clamp around the ICV valve wire. And what the ICV valve is on this type of bus, it's just basically a big fuel injector, okay? And it's mounted on basically right on top of the distributor housing on the back of the injection pump. And how it works is every time the rotor on the back of the distributor lines up exactly with the ICV valve, okay, the ICV valve will fire into that little slot. Then it goes through that slot through your fuel line to the proper cylinder. And how it knows when to fire that valve is by looking at your engine speed sensor and your camshaft position sensor. Okay, so it looks at those signals to know when to open that valve at the right time for the proper injection event. Okay, so anyway, so after that, then I took a high amp clamp and I put it around a battery cable. Okay, so why am I doing this? Okay, I want to see the relationship of when the injection control valve is firing to top dead center. Okay, I want to see base injection timing, and this is while I'm cranking the engine over and I've disabled the ability for the injection pump to put fuel into the system. And I did that by disconnecting the pumping plunger solenoids on top of the injection pump. Okay, and the pumping plunger solenoids on the top of the injection pump are basically little valves that let fuel into the plungers at the right time. It opens, and then the camshaft on the bottom of the valves on the lobe, on the very top part of the lobe, it pushes up on the valve, compresses the fuel, and squishes it. And then at the right time, then it's energized, and it lets the fuel out. Okay, and then that's how it builds pressure. It goes into that accumulator module, and then once it gets in the accumulator module, it goes through a rate-shaped tube, a twisted tube, and that's to help with the timing. And then it goes down to the injection control valve. Okay, so anyway, if base injection timing is wrong, you will get intermittent speed sensor codes. All right, that's why I'm doing this. So we'll go to the next slide now. Here's my evidence. Okay, so let me get a pointer tool here, laser pointer, and I'll walk everyone through this. So on channel A, I've got the engine speed sensor because I want to look at the integrity of it. And then on B, I have the engine position sensor. Okay, it's a 5-volt square wave. It's a pull-up design, which means it gets a positive signal from the sensor to the computer. Okay, for those sensors. All right, and then the green channel, channel C, that is my injection control valve current. Okay, so this is showing it when it's firing, when it's sending fuel into that notch in the distributor at the right time for injection to occur. Okay, so anyway, and then on the D channel, I have the starter current. Okay, now I want you to pay attention to a couple things here. If you look at the starter current, see how the starter current is kind of wavy? It's like, oh, I'm high, and then I'm going down low, high. And then if you look here, I've marked out the timing. I've got some degree markers here. I just went top dead center from the first cylinder here, and then to the last cylinder, full 720 degrees. Firing order on the engine is 1, 5, 3, 6, 2, 4. Then you start over again. Okay, and I marked it out when it was firing, and my timing is 15.62 degrees before top dead center. Okay, that is way too much. That is the injection timing is advanced too far. It's firing too soon. Okay, so I saw that, and I'm like, well, that's my issue. Something's going on here with the base engine mechanical. Okay, and you can also see how it's wavy. All right, so after I saw that, I took off the valve cover and I started checking the valve lash on all the valves. Okay. All the valves, they were at their max lash limit. Okay, so due to the looseness in the valve train, the computer was logging a false code for the signal being lost. Okay, so I readjusted the overhead, and here's what the base injection timing is supposed to be. Look at that. It's a lot better. My starter current is a lot more even now. This one's a little bit low, but it's way better now. Okay, and then also look at this. Okay, here's the ICV firing. Okay, the first event here is pilot injection, but the second one here, this is main. You want to look at main injection on your base timing. Okay, so anyway, I did the degree cursors again, and I've got 3.98 degrees before top dead center. Okay, that's where it needs to be. It needs to be very close. That is a huge improvement. Okay, so after I did this, the bus was fixed. It never came back. So, did I prove it? Yeah, I did. Shows the ejection timing's better, starter current's more even, the bus didn't come back, and another thing to point out, if you looked on the tone ring captures, okay, I've got some noise on there, but that's usual because I'm cranking over with the starter motor. But if you looked, I didn't have any teeth missing. It held proper signal. It didn't deviate. So that just proves right there that the tone ring on the back of that camshaft is fine and there's nothing wrong with it, okay? Just imagine, okay, if you had a problem where you had a kind of like a similar issue, but on this one it was throwing the intermittent speed sensor codes and causing intermittent low power. You check the overhead and it's fine, but it's still doing it, okay? How are you going to be able to verify if that tone ring is good or if you're having a problem with the signal without a scope, okay? And the only way you're going to be able to verify if there is something wrong with that tone ring is you're going to have to rip apart the timing cover, potentially have to take out the injection pump, maybe. So that's a lot of time wasted, okay? You want to do it like this, okay? It took me less than like 20 minutes to hook up and do this and look at that and find that problem, okay? Compared to, if you don't, what's average time on, ripping a cover apart and looking at it? It's probably about an hour. It could be more. I can't remember, but it's more time, okay? This is the way to go, all right? So, so anyway, that's the end with this case study. And this is the next one here, just a sneak peek here. This one's got, low power on acceleration. This will be the next one we do, but I'm going to stop here for now, and then we'll start up with the next part. So I hope everyone enjoyed that, and I will see everyone again soon. So take care.